Hey everybody, last lesson, 7-8, geometric sequences. I'm not going to stay on this page too long, it's getting me all doozy. Our objective here is to write and use formulas for geometric sequences. Okay, I'm done with that. So, here's a table that shows the height of a bungee jumper after it bounces. Well, bounces is really the wrong word, but bungee jumping, you jump off, bungee up, that's a bounce, then bounce, and again, bounce. So after the first bounce, they have a height of 200. Then after the second bounce, it's a height of 80. And the third bounce, it's a height of 32. This shows what a geometric sequence. What do you think a geometric sequence actually means? All right, well, read the note now. So a geometric sequence, it's the ratio of the successive terms, meaning the ones before it, is the same number r. It's called the common ratio. Pretty much all a geometric sequence is an exponential function, but the input can only be positive integers. All right, so it's discrete versus continuous. All right, so it's really just piggybacking off of our previous lessons of exponential functions, but now it's discrete because it's individual points for a geometric sequence, whereas an exponential function could just be continuous and we could plug in any numbers. So that's just the brief difference between the two. All right, so this is a geometric sequence because there's a common ratio. All right, what are the next three terms? So the first thing we have to do is check out what's going on. Times 4, times 4 times 4. What are the next three going to be? Hopefully you got it. Now, you got to be careful sometimes because the cool thing about a geometric sequence, it could alternate between positive and negatives, because when we multiply by a negative number, that's a pretty straight line. When we multiply by a negative number, it alternates between positive and negative here. So here, it goes from 1 to -2 to 4 to -8 to 16 and so on. So here, it's still, we can't say it's doubling because it's not, but my R value here, my common ratio, I know that's another new variable. I just threw it in there, but this is pretty much what we multiply by. My common ratio here is just going to be -2. All right, if I take any term, I multiply it by -2, that'll give me my next term. So find the next three terms here. Obviously laid right into this one, right? Hopefully you got it. What about the next three here? Before we do this one, we definitely want to find R. In order to find R, we got to figure out what do we multiply by to get here. Well, it's a really tough number because it's getting smaller. So you might think, well, we're going to divide. Geometric sequences, we're always going to multiply. In order to figure out what we're going to multiply by, we first have to divide backwards. So I'm actually going to do 288 divided by 384. And yes, that's going to give a decimal, but that is what my R is going to be. Okay, so what's your R? Good. Now that you have your R, now you're going to take that R and you're going to multiply it by the previous term. And now tell me, what are the next three? Hopefully you got it. All right, so now we're going to get into the formula for it. All right. Well, here it is. All right. I kind of skipped breaking it down and explaining every little piece of it in my long-winded way. I'll cut to the chase. A sub n. All right, we should be kind of used to subscripts now. This just means the nth term, whatever term I want, A sub n will equal A sub 1, which is my first term. This is going to be the first term of the sequence here. You plug it in right here. Notice right next to it is my common ratio, my R. What do I multiply by? These two get multiplied together. Then there's an exponent on the common ratio. It's going to be n minus 1. Whatever term number I want, my exponent on the common ratio is going to be 1 less than that. The reason it's going to be 1 less than that is I already have my first term involved. Since I already have my first term, I don't need what term number I want because I already have one of them, so I need 1 less than that. Okay, now that may make not full sense quite yet. I know we like to see examples. I have some examples, of course. So Here we go. The first term of a geometric sequence is 500, meaning it starts at 500, and the common ratio is 0.2 or 2/10. So this geometric sequence is actually going to get smaller and smaller and smaller because my common ratio is less than 1. This is actual like exponential decay. All right. So I want to know, what is the seventh term of the sequence going to be? So here is my basic geometric sequence formula. A sub n equals a sub 1 times r to the n minus 1 power. I know that sounds so crazy, all those r's and n's and a's. All right. But what I'm going to do is I'm going to plug things in first. All right. I want the seventh term. So a sub 7 will equal my first term, 500, times my common ratio of 0.2 to the 7 minus first power. I wanted to show you that I didn't just want to write 6 this time, but that's just going to be the sixth exponent because I want 1 less than 7. I carefully compute this just like I did in the past, and I get a very small number, 32 thousandths. All right, 32 thousandths. That's the seventh. It starts at 500. 6 terms later, it's all the way down to that small of a number. All right, crazy. All right, what's the ninth term of this sequence? Wait, it doesn't tell you the starting amount, doesn't tell you the R. Well, it does tell us the starting amount is 2. It doesn't tell us the R, so first find the R. What's going on here? Find the R. All right, hopefully you came up with -3 as your R. So now my formula is going to be a sub 9, because I want the ninth term, equals 2, my first term, times -3, which is my common ratio, what I'm multiplying by every time, to the 8th power. Now notice it's the 8th power because I want the ninth term. I already did 9 minus 1 to get that 8. That's where this 8 comes from. Okay. Now I just compute it. I'm going to have to, I can just type it in the calculator. If I didn't, I would have to do -3 to the 8th power and then times it by 2. And that gives me -13,122. A very, very small number here, you know? The last little tidbit of information, if you do have a negative R, if you find your common ratio is negative, you have to put it in parentheses. The reason you have to put it in parentheses is, recall, a negative number needs to go in parentheses with an exponent. Otherwise, it won't work out properly, especially if we use a calculator for this, okay? So if your R is negative, be sure you are using parentheses. All right, and that wraps it up. You have 2 Khan Academies to do, then your mastery check, and there's 2 more IXLs if you would like to do some aspire to do's. There would be really good practice, but again, a little above and beyond than where we need to be, but it will definitely be beneficial.